So this is where on the right we have our laser module. Right here we have our mirror. We have a kind of little slotted area where this probe holder will slot in. And then we have our photo detector here. So if I go ahead and place this, as I said before, there's kind of slots here and here that it rests on. So if I go ahead and place it onto there, it sits on track, and then you just push it back and it will magnetize to the very back.
Removing, you just pull it out.
Yep, removing, you just pull it out. You also want to make sure that there's space between the probe holder and the sample, so don't pull it out whenever you're like right above the surface. Because it's very easy to ram it into the surface and then it damages your sample, breaks your probe, absolutely. And it's just not a fun time. Okay, so the Alright, so I'm going to walk you through kind of just a basic idea of the AFM. So we'll go over the different parts. So, to start off with, as far as cables, we have a USB cable that goes to the USB top view camera, as well as a tube in the side that is our light that illuminates. So you can see dark, light, dark, light. These should not need to be changed, but obviously if you're going to eventually put it up onto an optical, then everything is going to kind of have to be taken apart. In addition to that, if you ever need to move the AFM, as in pick it up and move it somewhere, everything should be disconnected, so the cables at the back should be disconnected, and those red brackets that I showed you earlier should be put on. You don't have to tighten them all the way, you don't have to torque down on them, just screw them in to the point where it will stabilize this. Because this is very fragile, and if you break it, you have to send the entire thing back to us. And that's not fun. As well as that, just moving down, right here and here, you'll notice our knobs sticking out. If you look at the camera software here, whenever I turn this, it moves up and down. And whenever I move this one, it moves left and right. Additionally, at the back here, just a second to... Okay, so at the back of the AFM right here on the right side, you'll notice this silver screw with this black knob on top. This will adjust your focus. So this is where you'll be able to go between focusing on your sample and focusing on your probe.
That's the
There.
it's the copper.
Additionally, moving down a little bit more, you have a locking knob. So because this is a tip scanner, tip scanners are far more susceptible to ambient vibrations, causing issues with noise. And so one thing that you can do to help assist with that is, say for example, we are focused on our sample, then if we turn this focus, or turn this knob here, what it does is it locks it in place so that it's no longer able to move. And then you can just give this a couple of turns the reverse way to disengage the optics from the rest of the microscope. So now, rather than the scanner having the light lever and the optics weight on it, now you've reduced the load and the camera is completely removed from the scanner, so it's not going to add noise. This is something that's important to do. You will notice significantly better noise with it like this versus with it unlocked. So whenever it's unlocked, you can see
Mhm.
I can move this up and down. Whereas once I lock it, it's locked into place, and if you unscrew this, just a couple turns, then now it's completely disengaged. Okay. Going on a little bit further down, you'll see this blue plate here. This is just covering the scanners, the XY scanner behind it. So behind this, there are X and Y piezos that will cause the motion that if I go ahead and press range check here, you can see that the tip is moving. And so what that's doing is it's just pushing an X and then pushing in Y. Which it still looks like that's not totally straight. Sorry, this is just my little bit of OCD kicking in. Okay. I'll leave it alone. So going on further down, like I said, this is the light lever.
Mhm.
So on the right side, you have your laser controls. Now that we have our cantilever in and we're focused on it, if I go ahead and turn this, you'll notice that this moves the laser spot up and down within the software. And then if I move the top one, it moves left and right.
So we should reposition. 0, 0. Where should we position the laser?
So the laser is going to be independent of this.
Oh, okay.
So
Okay.
what you want to do, and forgive me because this is going to stretch and look ugly. Actually, it looks really bad. So let's do it like this. So if you look at the cantilever, you see how the very tip of it is pointed.
Mhm.
So you can kind of draw a triangle where if you look at the base where it starts slanting and draw kind of a base there, you want the laser spot to be about on that base. So you don't want it to be too forward, you don't want it to be like this. If it's too far forward, you're going to be losing some of that laser light. You kind of just want to center it at the base, like that.
Mhm.
And then continuing to go down, and we'll cover this again. I just want to give you kind of a basic overview of the AFM, the things that you can manipulate, the things that you should not manipulate. I also didn't say this. You should not need to manipulate these, really, the camera controls. If you put a new sample in and you want to look at it, use these at the bottom, which if you look, this moves the sample. So if you want to look around on your sample, please use these. Do not use these. Because right now, we're set in a position where we can perfectly see the cantilever.
Yeah.
Whereas if I, say, want to go up and over here and I want to look at this arrow,
Mhm.
then now
There's.
I'm no longer focused on the cantilever.
No cantilever.
So whenever the cantilever is within the focal length of your camera, you should not need to adjust it. So if you want to look at your sample, use these.
Yeah.
Seems very simple, but there have been lots of times where I've had to walk people through how to find it again because they just like to mess with their optics. Okay. Additionally, at the back of the AFM right here, you'll notice this black knob. What this does is this is a manual motor. So the stepper motor is below this. However, you can also turn it yourself. So For example, if I lock my optics like this, if I start to turn, you can see that we're bringing the cantilever down to the surface. And if you look at this entire structure here,
Yeah.
you'll see that it moves up and down.
Mm-hmm.
And so that's just a good way to say, for example, if you look here, you can see kind of the difference between where the cantilever is and the sample surface. You can see there's a gap.
Mm-hmm.
So you can just use this to kind of rapidly reduce that gap so that you're not quite as far from the surface, like that. Don't go too crazy with it, because there's nothing that stops you from ramming it into the sample if you go too far. Okay. Should be everything about the AFM. As far as cables, like I said, there's a variety of cables. There's a USB here, there's a light cable here, there's a grounding wire here that allows any potential charge that builds up to dissipate through the system. At the back there is a 60-pin ribbon cable. I'm just going to go ahead and say this. In the future, if and when you move the AFM, please make sure that the 60-pin ribbon cable is fully plugged in. So if you look at the back of the AFM, which I will,
Yeah.
the rainbow cable should be pushed in enough to where these clips are clipped into place.
Okay.
95% of the calls that we get from customers are they move the AFM, those clips aren't all the way in place, and it's like weird things, like their motor's not working, or their range check isn't working, something like that. And so I just have to sit down and say, okay, we'll clip it in. But just to kind of visualize that can be a little bit of a headache in the future if you do move it. As far as cables, that should be it. So now we can jump into the software. Electronics box, or the e-box. If you look at the front, you'll notice all of these green LED lights. This is showing that it's on.
Mm-hmm.
If the power was turned off on this, then none of those would be illuminated. So you can use this as a good indicator to make sure that the e-box is on. The e-box always needs to be on before the control software is enabled or turned on.
Okay.
And that's just controlled. I'm not actually going to flick it off, but right back here on the lower left side, there's just a very basic power switch. Okay, so now we can go over the software. So, just going to go ahead and exit out of both of those. If we look on the desktop, you'll notice this AFM control software shortcut. Go ahead and double click on this. We'll open up the AFM control software. A little error message will pop up that will say, well, maybe, never mind, it didn't pop up. From time to time, an error message might pop up that says error scanner needs to be calibrated. If that pops up, you can ignore it. It's just a bug that kind of pops up every now and then. Like I said before, calibration is at your own transgression. If you want to do it every 3 months, every 6 months, every 12 months, obviously it's your AFM, so you can choose how to kind of maintain and go through that process. Going over the AFM control software, you'll notice that there is a tabbed architecture system. So we have pre-scan, which has all of our pre-scanning adjustments that we're able to make. So this is everything where you're going to be able to go through and adjust parameters before scanning. We have topo scan, which is where the actual images will show up. And then we have our advanced force distance tab. This is where you're able to, say, take a non-vibrating mode image here, and then you can create a, like, if I go ahead and set it up like this. So if you took an AFM image in non-vibrating mode, then you would get that image here. And then from there you can set up a mapping, single point, you can choose your grid size. So if you wanted to, you could take a 64 by 64, where each one of those will just go down and take force distance curve at each point. And so this can be very useful for kind of force mapping. So for example, if you had a sample that had a lot of cells, and you wanted to look at the differences between the cells or between the cells and the substrate, then you could set up a grid and take force distance measurements on those cells and on that substrate to be able to go in and kind of analyze it from there. This is not something that we will cover in the training necessarily. This is something that I would recommend you go into and you delve into once you've gotten better at using the AFM. Partially because with the force distance we include 2 force distance enabled probes, and so I don't want to break one showing you guys, because typically once you use a probe for force distance, it's no longer good. So typically you're putting a lot of force onto that cantilever, and eventually it will like shear. So obviously, like I've said before, I will be available for further support once you guys get going, once you guys start playing around with the different modes, with the Duncan scan, so on and so forth. This is mostly just to cover kind of the basics of how to use the AFM. And then once you've gotten better at that, then obviously we can talk and discuss and figure out some way to hold a Zoom meeting with a 12-hour difference. But obviously, like I said, I'll continue to support you. Also, right there, can you grab that book of manuals? So this also has all of the various manuals. So there's the Duncan scan manual that walks you through the setup and running Duncan scan. There's the advanced force distance that goes through all of the setup of advanced force distance, how to use it, so on and so forth. There's one that just talks about just the AFM control software and all of the different parts of that. So all the different parameters, what they change, what they do. What was that? Oh, okay. So I have to say, please don't be more things blowing up.